Hello, in this video, I want to show you how to perform a propensity score matching analysis using R. The propensity score is the probability that an individual receives the treatment given their observed characteristics. Okay? And the propensity score is used in observational studies to create a balance between treated and untreated groups, aiming to mimic the conditions of a randomized controlled trial. By matching or comparing individuals with similar propensity scores, researchers can reduce bias due to confounding factors. Propensity scores are commonly estimated using logistic regression models based on baseline covariates. And methods used propensity score include matching, stratification, weighting, and covariate adjustment to estimate treatment effects more reliably. Effective use of propensity scores depends on carefully choosing relevant covariates and checking that treated and untreated groups are balanced after adjustment. Okay. And for this video, I want to show you how to do matching after propensity score estimation. Okay. So we're going to need the library MatchIt, and then I want to also load dplyr for data manipulation. Set a random seed, sample size is 200. We create 3 covariate: age, gender, income, and we assume a logistic model for covariates for treatment assignment. So logit and then probability, and generate the treatment variable using the probability. So this is we assume to be the true mechanism for treatment assignment, and create an outcome as a function of the treatment, age, gender, and also random error term. We combine this into a data frame, and here's what it looks like. So this is the observational data set. And by the way, we only have 3 covariates, and the strength of propensity score is really you can match on large number of covariates as potential confounders. And usually, to use propensity score, you want to have observational studies with large scale, large sample sizes. Okay. All right. Here, let's see how we're gonna do the matching. One matching method is called the nearest matching. So this is match treated with untreated on covariates, age, gender, income, using the nearest neighbor matching without a replacement. So you can see the syntax MatchIt, then treatment regress on age plus gender plus income. That's the logistical model for estimating propensity scores. Data equal to data, method equal to nearest, ratio equal to 1. So we're doing 1-to-1 matching, and replace equal to false. Okay. So if we run that, then you can see the summary. You got 61 controls matched to 61 treated, and there are 78 controls not matched. And after that, we can extract the matched data using match.data on that matched object. And we're going to run subsequent analysis on this matched data set. So basically, we'll just run linear regression on outcome, regress on treatment. And we don't have to adjust for other covariates now. And then the summary look like that. Okay. So you can see the treatment is highly significant here. Okay. So the R package MatchIt has a lot of different matching method. The other one is the exact matching on the exact covariates. So here, if you specify method with exact, it can match on age, gender, and income exactly, okay, as much as they can. So here's the summary. And also it matches 61 to 61, okay? And you can run subsequent analysis, get similar results. And now the p-value is very small, so indicating significant treatment effects. But the estimate, the beta estimate for the treatment effect is a little bit different when you use different matching method. The next one is you can do partial matching. So what that is, you can do some exact matching on some covariates and then nearest method, nearest neighbor matching for some other covariates. So here, for example, we can say exact equal to tiered gender. So we're going to do exact matching on gender, which is categorical. And then we do nearest matching on other covariates. And this is a summary. The matching is still similar, match 61 to 61. And then you can do the subsequent analysis for causal effects. Okay. Another matching method is called CEM. It's a cohortant exact match. It is cohortants continuous covariates into beans and then applies exact matching on those grouped values, improving overlap while retaining comparability. So it's more difficult to match exactly on continuous variables. So if we categorize them into beans, then it's easier to find a match between the controls and the treatment group. And the syntax is everything's the same except method equals CEM. And this is the output. You can see the ESS, the effective sample size. You can see now the sample size for controls has decimal points. Okay, so they're not exact matches, but it does it as much as possible. So sometimes you end up as a sample size with the decimal points. Okay, but the subsequent analysis for causal effects are similar. So results also similar. So next one I want to show you is the optimal matching, which minimizes the total distance across all pairs, requires a package optmatch. So that package I have installed here through some efforts. But when you call the optimal matching method for MatchIt, you don't actually have to load the optmatch library. It's going to do it automatically. So if you do that optimal matching, you can see here the results still 61 to 61, but the subsequent matching, subsequent analysis for causal effects is similar. Okay. All right, the next one is full matching. This assigns treated and controls to groups that minimize average within group distance. So that's another optimal criteria. The syntax is just method equal to full. And here, this is what it matched. Again, you got the effective sample size with decimals. And then you get the subsequent analysis. So you can see the beta estimate for treatment effects is still a little different. The p-value is similar. Okay, it's very small. Okay, now this one is more interesting. It's a subclassification match. So it divided data into strata based on the estimated propensity score, commonly using quintiles. Usually you have 5 subgroups. So the syntax is very similar, just to match it. And then data equal to data, method equal to subclass. But you need to specify subclass equal to 5. That's for quintiles. And then you can see you have more outputs here because it's going to divide into subgroups, 5 subgroups. So you have more output for the summary of the matched object. Okay. Then you extract the matched data and then do the regression. And then you got the summary. And now this is when you do this summary, it's going to do the comparison between the subgroups and then average them out, and you get the overall estimate. Okay. All right. For this method, I really want to add visualization, so we can load this library called the Cobalt. Okay. So there's a function called love.plot, and it will create a plot like that. So you can see covariance balance. The x-axis is standardized mean differences, so because standardized effect sizes for all covariates, so they can be compared on one chart. And the y-axis are the distance and age, income, and gender. Those are the covariates. Okay. And you can see there are red dots and blue dots. The red dots are unadjusted, and the blue dots are adjusted. And you can see the unadjusted dots are away from 0. so they're not very well balanced. But the blue dots are closer to zero, so that more like a better balanced out. Okay, so this shows the balance brought by propensity score is pretty good. Okay, so now if you plot out, you can add the jitters to these quintiles, and then you can see what are matched, how many matched controls and treatments are in each quintile. Okay. The summary of distance, I tried this one and it takes a long time, so I am gonna end it. And you can use the standardize equal to false, and it immediately give you the results. Basically, give you the sample sizes and the subclasses and the means treated, means control, and all that. And then for all the data, and then cross subclasses. Okay, and you can also create balanced plot. Look like this is a really very informative plot showing you the distribution of the the age variable in the 5 quintiles. Okay, and this is very informative. You can show it to non-statisticians; they immediately get it. And similarly, you can do for the income. Okay. Okay, and the last one is Mahalanobis distance. So this is the multivariate statistic distance measure, but you can use it, and you can use it. Say I want to match on age and income, because to use this the Mahalanobis distance, the variables has to be continuous. Okay, and then you can see the um, matched result summary and then do subsequent analysis. Okay, I think that's all I want to show you about how to do propensity score analysis and with different matching methods using R. Thanks for watching.